In this video, we'll be looking at algorithms. In particular, we're looking at the how you implement queues and stacks, how you might make use of them as functions, and we had a little look at using files. We'll have other questions on different algorithm questions as we go along, and these are questions 2 and questions 4 in the pack of questions. Welcome to this latest video. We're going to be looking at all of the algorithm questions from the OCR Computer Science A-level pack of questions. There's a huge variety of questions we've got on here. We've got sequences, we've got ones around sorts and searches, we've got ones around pathfinding algorithms, we've got questions around data structures and applying algorithms to data structures. This is a huge source of questions in the paper 2. Indeed, I'd say maybe 40-50% of the questions will come from these type of questions in paper 2. So it's very important we get these ones right. To kick off, we've got a question here. It's question 2A and 2B from the pack, and it's saying a program stores a queue of mathematical questions to be asked by a user. The phrase queue. So yeah, queue is a data structure, and it's sort of deliberately put there. As we're going along here, it should be sort of tweaking some ideas inside us that a queue is what kind of a data structure? Well, it's an abstract data structure, is it not? Because ultimately, the way we access a queue is through its methods, such as onQueue and dqueue and full and empty, right? These methods, and underneath it, the real data structure is happening, which is probably an array of some sort, and it's going to move things around. Okay. Also, what else we remember? First in, first out. 2 pointers, header pointer, tail pointer, people, items. Join a queue at the tail, leave the queue at the header. Could be implemented inside the list. Could be implemented inside an array. All right. The questions are asked in the order they're added. So that works perfect for a queue. If you wanted to ask questions in a different order, could that work for us? No. You'd have to dequeue items, wouldn't you? So you have to dequeue items until you got to the one you wanted, and then stick it back, and it would be terrible. Once a question has been asked, it cannot be asked again. So once it's removed from the queue, it can't be asked again. And new questions are continually added to the end of the queue. Okay. So, when you're hearing the queue, it should trigger some thoughts. So it could be implemented inside an array. And if it's implemented inside an array, what's going to happen is that items will be leaving from the front. So space will be created on this side. Items will be added to the back. And you see what will happen eventually is that there'll be no space to actually add items because the space you need to use is over here. Do you remember how you actually solve that problem? By making use of a circular queue. So essentially that this goes back in here. So then, the tail can go back this way and then spaces can be used. It says specifically here, the program will use a non-circular queue. So you are going to have an issue eventually where you're not going to be able to add additional questions because the free space that's been created at the front won't be able to be used. The pointer head stores the index of the first element. So that's the index here. That would be where the head is. The pointer tail stores the index of the last element. So I guess that would be there. So in fact, I'm going to just write on here. So that's HP head pointer, and that's TP tail pointer. Sometimes the tail pointer is said to be pointing at the next available free space. So it depends about your implementation. In this case, it's pointing at the item because it says so here. Head pointer nearly always is going to be pointing at the item to be removed, unless it's an empty queue, which in case it can't be doing it. And then we can imagine as items are removed, the head pointer will move up. When the head pointer and tail pointers point at the same thing, well, that means that it will be empty. And tail pointer, how do you know it's full? It's when it goes into the next, is when it's pointing at the last position in the array. Because once it's got up to here, you can't add any more items. Cool. Oh, and when it says index, bear in mind, remember what we mean by that. So it'll be like 0, 1, 2, 3, 4, 5, 6, and 7, the index of the array. Wicked. Describe why a queue is suitable for this structure. So what do we know about a queue? That's what we should go from. We just talked about a bunch of different things. What do we know about a queue? There we go. We know it's first in, first out. So I'm just going to write that down and then link it. I've said it. How does it help me? Yes. Items are added in the order that they are added to the list, i.e., as questions are added to the back, it will be the first question you add will be the next question out as things go on. So it fits with the way that questions are added and removed. So that's 3 marks. Have I got all 3 marks? So I need to be a bit more specific in the way I say it fits with the way questions are added and removed. Is that specific enough? No. So when I say it fits in the way, questions are added in what way? So, and in order, questions are added in order, and what position? Well, at the back, yeah, which is where it's going to be. So, the questions are always added at the back of the queue. Of the queue. What about the where questions are always removed? Now that might seem obvious, but unless you spell it out, no. When I say it fits with the way the questions are added and removed, I'm being too vague. You need to be specific. So questions are always added to the back of the queue, and questions are always retrieved from the front of the queue. Let's look at marks. Where can we get marks in here? Do we get a mark for saying it's first in, first out? Yes. Do we say that questions are always added at the back of the queue? Hopefully, yes. And we say questions are always removed from the front, and that's why it's fitting it. I'll look at the mark scheme. Queue is first in, first out. There you go. And then we're saying the questions are retrieved in the order they are stored. So whether I'm saying I'm being specific enough, that's the question. Questions can be added to the end. Well, questions are always added at the end. That's the only place they're already added. And then, it's a dynamic data structure. When we had a big conversation about this, what's the definition of a dynamic data structure? Well, something that can grow and shrink whilst the program is running. Yeah. A static data structure whilst the program is running. There we go. So I suppose it's a tricky one, isn't it? Can the queue become larger in the sense that can you add an item on here? So it's becoming larger, but within the constraints of the array. Can it grow and shrink? The queue itself can get smaller. I understand. Yeah. So the array itself is always going to be 7. But it's almost like a philosophical concept at this point, isn't it? But the queue can grow and shrink within the constraints of the array, and more than just the constraints of the array. Also, it can't grow and shrink after it's got here because it can't use the free spaces. You'd almost feel it was a more legitimate argument with a circular queue. But I suppose if you just go to the key definition which is a dynamic data structure can grow and shrink whilst the program is running. Can it? Yes. Can an array grow and shrink under any conditions? Well, whilst the program is running. So therefore, do you mean that's a hard understanding that it's a static data structure because you could never make it bigger or smaller whilst the program's running? Yeah, exactly. And now there might be empty those spots. It is almost like a philosophical conversation here. So I suppose it's dynamic in the sense it can grow and shrink, but within the constraints of the static data structure in which it's implemented, i.e. the array, and also with the limitations that it's not using a circular queue and therefore it can't use the free spaces. Right. 1. Shows the contents of the queue shown in 4.1 after... Oh, here we go. So show the contents of the queue shown in figure 4.1. Boom. After the following code is run. So add 6.1. So that what they're asking you to do. Well, let's think in here. Is tail pointer. Where are things added? So tail pointer will increment by 1. I suppose there should be some kind of test that there is space enabled you to do that, but we don't have to worry about it for a moment, and that will drop in there. So what am I actually going to write out?
The head doesn't move.
Well, I mean the header and pointer I've just put in there. The header won't move. Yeah. So what do I actually write here? So I have to write out all of this. Yeah. Okay. So make use of your copy and paste and cut out and paste the tool that you have on your piece of paper in front of you. Would you have to actually write and copy in all these spots here? I knew you'd say that. You do. You'd have to write them all out. I'm asking you to, but it is the way it is. So there you go. So I've written it all out. My handwriting has improved dramatically. And now I need to add in the new item. The new item is going to be at the tail pointer. Tail pointer increments, so it'll be in this spot here. And I'll need to put in this. So I'm going to add in 6 plus 1. And as we identified, putting it 6 plus 1 like that, I'm not holding it in the right way. The speech mark signifies that it's a string, and therefore it will be important that I'm consistent with that. Presumably what's happening is that there's some kind of a string manipulation going on that takes the first, maybe it probably splits it where it finds the first plus or minus or whatever, takes what's behind that as the first integer, takes what's in front of that as the second integer, and then use that as the operation. Beautiful. What's next? State the values stored in head and tail after the code in part 1 has run. Where's my code in part 1? Oh. So what's actually held in, so header was pointing at here. So state the value stored in in the head and tail after the code in part I. Where is the code in part I? Oh, 6 plus 1. So as we can clearly see now, what we might get confused by is the difference between the pointer value, as in the value that the pointer is pointing to, the index, and the value that's being held at that position. And this is asking about the value of what the head pointer is pointing at. And what's it pointing at? It's pointing at position 0. At position 0, it's holding these values, but the actual value of header would be 0. And tail pointer, originally it was pointing at index 4. At index 4, it was holding this contents. We then added an item and incremented the tail pointer. Now it's pointing at 5. So it's going at 5. Complete the following algorithm to remove and output the first element in the queue. So remove, normally this would be DQ, and it would be a function rather than a procedure. Why would it be a function rather than a procedure? Because you return the value. So this is just removing. Whatever's there, get rid of it. Quite why that's happening, I don't know. And then output. But output, it doesn't mean as in return it. It means as in print. Yeah. The first element in your queue. So to remove, in fact, let's do this super quick. Okay, so I've got my queue here, just a simple representation of it. And I've got my 2 pointers. These got nicked from my previous one I did in quicksort, so it should be pivot pointer and right pointer, but we're going to reappropriate them. P stands for pointer, and R stands for rear pointer. You're welcome. If we want to remove an item, can I remove any item I'd like from in here? No, I can only remove whatever's pointing in here. So whatever the pivot point's pointing at, I want to remove. The thing I wanted to point out was that the pivot point, it gets removed. This, what happens to this then? It increments by 1. And then what you might often see is this represented like this, with like a bracket around it. Now, what is that trying to signify? It's been removed, but it's logically been removed, but it physically stood there. You never deleted anything. So you just move the pointer up, and now, as far as it's concerned, that's been removed from the queue. But physically, on terms of, we talk about abstract and the real element of it. In terms of it being memory on side of the hardware, that's still there. Okay? All right, people. So, procedure remove. If I want to remove something, what do I need to check for? If I want to remove something from a queue, what should I check for? That's got stuff in it. I want to check to see whether it's not empty, essentially, yeah? And if I want to check to see if I want to add something to a queue, what do I need to check for? If it's full. Bingo. Now, we can think this through really quickly right now. The pointer comes up. The rear pointer points at the last item, correct? Then we want to dequeue this one, and it's going to move over here. We're going to dequeue this one, and it's moved over here. Yeah, let's logically think this one through. So I was here and here, yes? So how does it work? I remove this item, and then I increment it. Yes? I remove this item and increment it. I remove this item and increment it. I remove this item, increment it. We should end at that position. And remember, this was the head pointer, and this was the tail pointer. So what position are we going to see where it's actually empty? Yeah, that could be one way of doing it. If head pointer position is greater than, yeah, in the way they've got it structured right here, or if head pointer or if tail pointer is equal to head pointer plus 1. So if we write up the actual index, 0, 1, 2, 3, 4, we can say, yeah, if you're right, if head pointer is greater than tail pointer, in the way we're looking at it right now, it indicates it's what? It's not full. What is the opposite? Empty. Yep, there we go. Whereas, or we could say if head pointer is equal to tail pointer plus 1. Yeah, that would also work for us. Yeah, which is what we've got here. Beautiful. So let's write that up in either way. So what am I going to use? Selection statement. So I'm going to use a if. I like the it's greater than, yeah. Because, it's only catching that one condition, but it makes sense, right? So if what? We've got head and tail. If head is greater than tail, although having said that, on here they've gone is head equals tail plus 1. Yeah, equals tail plus 1. But ultimately, this logically makes sense. Oh, I don't know. What should I do best for you? Because what happens if it goes to an examiner and they're like, greater than tail? Yeah. You know what we're going to do? We're gonna do what they... Just because I want to set you guys up. You know what I mean? It's completely right. It will completely work. Exactly. And I don't want a situation where you go off, someone marks it, and they go like, greater than... What's they talking about? Like, I hear you. Like, I hear you. You understand? Morally, ethically, I'm with you, right? But the game is, right, that we answer it in a way where they're like, that, yes, rather than you're leaving up to chance, which you think is the most likely thing is that you've got somebody who knows what they're doing, who go, oh yeah, that makes sense. I don't want to leave anything to chance. Well, as little as we can. So it's equal to, what do we say? If head is equal to... Yeah, tail plus 1. Yeah, double equals for comparison, single equals for assignment. Plus has a bit here and a bit here, so I'll include that. All right, if it is, then what does that prove? It's what? Yeah, so print, what's the message going to be? I know, it's empty. The queue is empty. There you go. So when you get a stack question, when you get a queue question, and it's about adding or removing, always check whether it's full or empty. That validation, that's a classic question, comes up loads. So yeah, as I say, it would be the same as if like, let's check to see if you can add an item. I don't know whose voice that is. In this case, look at my model here. I'll go back. How would I know that I'm actually that my list is full? It's non-circular queue. How would I know it's full? Yeah, because the rear pointer is always looking at the last position. It's now pointing at 4. If rear pointer is pointing at how we find the end, well, we can have the length of the array it's in. If the length minus 1, because I guess the length of this would be 5. If rear equals length minus 1, or whatever the name of the array, length 1, then it's full in this context. In other ones, it would be different. If it's circular, well, circular depends on your implementation. Empty might be that they're on top of each other. Full might be that the pointer's gone around and actually gone the other side. What happens if it was implemented in a list? How will you check if it was full? It was implemented in a list. That is a trick question. It wouldn't be because a list is a... So we could always just add more. How would you check if it was empty in a list? Could you still be empty in a list? Yeah, you still could be empty. So yeah, wherever it'd be something like this, whether it's either on top of each other, the two pointers, or whether it's one next to each other, like this implementation. Because like in some implementations, sometimes the pointer doesn't point at the last item. It looks at the last space. So, and then in that case, if you think about it, it would end like that. Yeah, when they're next to each other. It depends on the implementation. And they've done the work here, haven't they, of telling you at least what implementation they're using. Beautiful. So the queue is empty. Am I finished? Not even close. Else what? Beautiful. Well, it not just said... remember, yeah, because here, do I set this as blank? No, I don't have to. Now it's not part of my queue. I just move this up, which will be, how do I move that up? Head plus plus, or, yeah, head equals, do you know why they do that? It's because in Python, it's like equals plus 1, isn't it? I blame Python for all the ills of the world. Yeah, and now you're on the other side of it. You're like, do you know what I teach on my GCSE? We got, I mean, logically it kind of works. We've got some syntax errors. What are our syntax errors? We have to end the if. Hey, what's this for, by the way? Where you got if starts here, end if starts here. It's describing, begins with S, scope. Oh, it is selection, but scope. Where does the if statement begin? Where does it end? How do you achieve scope? How do you indicate scope in Java? By using curly brackets. Yeah. For Python, how do you do scope? Indenting. Yeah, exactly. It's indenting. If you don't indent in Java, it's not the end of the world. But why do we indent? Because... Bingo, there we go. I need to do my last bit of scope. I've said where the if started and when the end is started. What have I not said? Where the procedure starts. Oh. Done. Taken care of. End procedure. All right. Complete the following algorithm to ask the user to input a new question. Oh, there you go. All the stuff we just talked about, it's going to be relevant, isn't it? Nope. Oh, it's just being extra. And then it turns out being extra sometimes is just being the right amount. So, to ask the user to input a new question and either add it to the queue or report that the queue is full. All right. So let's come back to my model. So this is actually pointing at the last item, is it not? I need to use this then to make a judgment as to whether it's full. Oh, I've given you some information. So I was saying that you could call questions.length, or whatever the name of the array is, rather, that sits inside to get it. Here they've actually told you the maximum number of elements is 10. In here, what's my maximum number of elements? 5. So do I say when the rear pointer is pointing at 5, I'm finished? No. It's the length, max length, minus 1. So that means the one place where you might go wrong here. All right. Should we go? Oh. We need to ask the user input. So let's do. So wait. Let's break this down a little bit as well. Complete the following. Ask the end user to input a new question. How do you do that? Should we just do that now? Let's. So we need. Okay, but we need to store it as a variable. Yes. Oops, that's not helpful. So I'm going to have my new one, very imaginative. I'm going to call it quest, which is actually not a great describe because it actually does mean something, doesn't it? I'm not changing it, but whatever. Quest equals, what's the function to actually ask someone to input something in? Input. I know, tell me about it. Open bracket, and then as a parameter, you can send this, the question. Enter question. I would normally say please, but you see where I'm at. There you go. Question is input a function or a procedure. Difference between a function and procedure? Does input return a value?
Yeah, it does. It returns it. It's a quest.
So actually, input is a function. You send it the parameter of the question. It presents it to the user. They type in whatever they're going to type in, and then stores it in quest. Yeah, so that's a function. Always like to, chuck in those things like that. No, well, the whole thing's a procedure. It says it, but that's why, because they're not talked about functions. I thought I'd chuck it in there. It's worth saying, can we ever have a procedure with a return statement in it? No. That's the very definition of a function, is that if it's got a return statement, it's returning that value and it's sending it back. Just like here, with input, there must be a return statement and it's returning it back there. Now I need to check. This is my validation. What am I going to validate? If I'm putting things into it, what do I need to validate? That it's not full. If it's empty, Molotov, go for it. But full, that's my issue, right? So how do I, what kind of thing do I need to check for? If, am I right? If, yeah, go on. If tail, yeah, so I'm talking about this side here. Where was I? If tail equals max elements so some mistakes I've made. Yeah. Equals equals, because single equals is for assignment, double equals for comparison. Yes, one more mistake. -1. So let's go back to it again. See here. Here's my model, isn't it? Yes? This is my model I was using. What's the length? What's the maximum number of elements for this? At what point do I know I'm full? When it's pointing to the last one, right? The last one is at index 4. So if the index is 5, I have to take 1 off it.
So how much is in the actual queue?
Well, it could only have because it's a non-circular queue. It could have 1 item in it, right? Bear in mind, this could be over here. In a sense, it don't matter because it's non-circular. As soon as you've got here, as soon as you've got the pointer at the end position, so I've done that now. It's full. Are there spaces in this queue? Yeah, there's spaces here, 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 and here, right? But because it's non-circular, can I make this come around here? No. So as soon as I've got to here, I cannot use that space anymore. The solution would be a circular queue so that then this could come over here and make use of these spaces. In fact, at this point, you'd say that this pointer could be over, well, if you want to add an item, then you add it up here, and you make use of that free space, which I cannot do. So I'm full when tail is equal to the max elements, so 5 minus 1. What should I say? That's full, that is. Powerful. Print. I could print the queue is full. I'm going to do that. So, what is my meta tip for you? As in not just this question, but data structures and different. Like, how long did it take me to knot this up? A couple of seconds. How much did it help me think through my question? Load, right? So my little tip, you can do the same with a stack, you can do the same with a queue, same with a lot of these data structures. Draw it, have your little pointers, and then you think, it helps you just visualize how it's going to work, and then you can implement your, like, realistically, if I just write the answer, but like, if I'm in your situation, I'm trying to remember how they work. Also, a queue, like I say, it could be different. It could be that it's pointing at the next empty space. In which case, would you have the same solution? No. And if you said, like, question tail equals max elements minus 1, when it should be just max elements, you ain't getting that mark. So, there we go. Beautiful. Am I finished? Of course I do. Of course I do. Because what happens if it's not full? I have to add it. Now, what do I have to add it to? What's the name of the data structure I'm adding it to? Questions. Oh, not for the first time. Our little model's going to come in handy. Right? Point to, say the rear. Oh, come on, don't die on me now. This is here. This is here. Right. Do I add it at that point? So maybe I plus 1 first. Yeah? So what's the name of that pointer? Tail. Yeah, it's a bit confusing. I should have got better pointers for this. Tail equals tail.
So can you not just do that as like, you say like questions, tail plus 1 equals question?
Yeah, you could totally do that. Plus 1. So I've moved it up. And then what's the name of my data structure? Questions. What kind of brackets am I going to use now? Square bracket. Tail. Now that I've incremented it. And what do I put in there? Equals quest. Okay, this is a great question for us to do because currently, how do we hold data? We hold it live when we're running the program in variables, in data structures, and when the program ends, what happens to that data? Crumples down and disappears. This is the equivalent, and we've done it in some of your projects, you would have done it, where you actually write your questions or write data to a text file. And that way, that when your program ends, you've got it held somewhere in an external file. When you restart the game or restart the program, it can load it back in there. I guess save game files is the same deal, isn't it? That you're saving to an external file, you're saving whatever's happening at that stage of the game, and then you close the game. All the data, all the active data, like the variables and stuff, is lost. You reload the game, and then it can load from the external file, and then give the information. So this is about how do you use an external file to.
How does the file how does it use the data?
Well, it's saved on. So think about it. I mean, we can bring it back actually to RAM, right? Remember RAM? It's volatile. Remember what was volatile again? That is what volatile means. Yeah, but it means that when the power goes off, all data's lost. So all the data in RAM is gone. So like you remember in year 7 when that person was really funny and they turned your computer off and then you lost all your Word document or your PowerPoint, right? So it's bloody hilarious. Yeah. Because it's in RAM. And then you were hoping, or maybe it's saved. Where's it saved it to? Secondary storage or to the cloud, which is non-volatile, right? When your program is actively running, your variables, your data structures, that's held in your RAM or cache potentially, right? So that means that when you shut it down, it's just gone. Unless you save it to a file that's on your hard drive or in the cloud potentially, and then that's non-volatile. It's going to be saved the state.
Every time you save it just saves virtual storage.
Yeah, well, if I save on my PowerPoint right now, it's going to be saving it to a file or maybe to the cloud. But unless I save, it's just sitting in RAM. And if I turn my computer off, or somebody else turns my computer off for me for a fun joke, then that data is lost. Which is one of the reasons why people try to switch on autosave. And people love their phones for this reason. Your phone, you're actively doing some work, you turn it off, but do you turn it off? You don't, do you? Yeah, you turn it to standby, and it goes into like a deep sleep mode. But is there still energy going in the background? Yes, which means that the RAM can still keep its settings. Yeah. Which is neat, like a lot of modern laptops as well. Like this laptop in front of me, don't be jealous if you're listening to the video and you can't see it. It looks beautiful, nice. Anyway, it's the same kind of design in the sense that any laptop really, it's still got, unless you shut it down, most of the time you put it into sleep, there's still energy so the RAM can actually keep its state. So that means that you can instantly turn on. But often we do want to use files. And this is one of the case. And we need to learn some things about opening a file, that we can opening a file in a couple of different states, in a read-only state, in a write state, how we then need to close the file. There's actually a little bit of learning that's going on here, and this is the perfect time to learn about it, he says. So we've got a function called read message. A function means then that it, beautiful. It takes the file name as parameter, as we can see in there, and it reads and returns a line of text. So it's reading it. It's a classic way you'd use it with a file. You've opened the file, and then you literally read a line at a time, typically separated by commas or something, called a CSV, and then you can read in that data. So we've got some stuff here. Function, so we need to have a good name for our function. File name, there we go. So I don't know. Yeah, what do we call it? Oh, it's called, read messages. Oh, there you go. I can read. Congrats. So we'll write read message. Message file equals open read, and what do you think you're going to send it there? File name, the name of the file. Yeah, so it might be like, I don't know, answers.txt or whatever, but it's whatever it's sent. So file name goes here. Message equals message file, so the one you've opened, dot read line. So it's going to read a single line from it. So it reads, and then it says it returns a line. So message file dot read line. After you've read the line, I was telling you about files that you need to open it, you need to close it. So this is something that's worth noting. The next thing you need to do is that, have I actually read the file I want to use? I've read the line. Then the next thing you do is then you'd close it because you've finished using it. So you'd run the file close. At some point we'll do some work on this, because it's not actually that complicated, but there's a few things you need to learn about it, like opening it in read mode, opening it in writer mode, closing a file, opening a file. You have to go through the steps. Although I dare say there's tons of questions on it in here somewhere as well. All right, I've done that. What do I return? Message, yeah, absolutely, right? The only thing, so let's have a look at this. A function push can be used to add a character to a stack. So we're on to our next data structure now, aren't we? So stack, let's remember what we think about a stack. What do we know? Well, it's not first in, first out. It's last in, first out. There you go. So we push things onto a stack for recursion. We push things onto a stack. One of the things you can use a stack for is having a word and reversing it, because you can put all the characters on individually and pop, and then I've just given my game away. So you push all the letters onto a stack, and then you can pop them off. How many pointers does a stack have? One pointer, yeah. Yeah, one pointer. Because where you point it in one place, it's only got one place of access and leaving. Okay, the stack.push B. In fact, I've got some beautiful diagrams, so I'm going to do another beautiful diagram right here. Don't be jealous. Your diagrams are also nice. Oh, whoops. So, and do you remember, this is my little tip to you. If you're struggling to visualize how these things work, and luckily, my 1p is going to do fine now because I've only got the one pointer, right? So the pointer's here. So the pointer will be pointing at yeah, I guess it has to be pointing at empty space, because if it was pointing at the thing, it would have to point there, wouldn't it? So it has to point at the next empty space, I guess. And then we'd add an item in, like 4. And then what would have to happen to the pointer? Move up by 1. Again, at some point, we might have to evaluate things being added to an empty... can you add items to an empty stack? Yeah, no problem whatsoever. I ask it in a very particular way. Yeah, of course I do. Can I add items to a full stack? No. So one of the things I'll have to do is determine, so probably the pointer is going to point at the next empty space. At some point, the pointer is going to be outside the array. So if I can find the size of it, it will be equal to, pointer will be equal to size of the array or size of stack. How dare you?
It's weird because
It's a stairway. Look, guys, here's what, I got a solution for you. Here's my solution. Turn your head to 90 degrees. I'm doing it because ultimately, you're right. I always visualize the stack because I described a stack, if I remember correctly, as like plates. Yeah. So you put plates up and you take, or stack of books. You wouldn't take it from the bottom because then all the plates would smash. I think the books would also go, so you have to take it from the top. But yeah, because the stack could also be implemented, anyway. And then how would I know if I couldn't, so that's how I couldn't add an item anymore. And then in terms of if it was empty, if the pointer is pointing at the first space and it's empty, probably indicate that. Anyway, that's where we're at. Coming back here. The stack.push B. So that's going to put... Oh, why did I do that? I could have easily... which is why I put a B there. It was always a B. Yep, because it's push B. So B's pushed onto the stack. Places character B onto the stack, the stack. This is the stack. Very imaginative name. A procedure push to stack takes a string as a parameter and pushes each character onto the message stack. So it's going to go along like this. Complete the procedure below. Add the comments to explain how your code works. Oh, and make sure to add the... If I've got a string and I want to push things onto the stack, all the characters from the string, can I just push it once? The whole string push it once? I'm going to have to go through each individual character and push it onto the string. So therefore, what am I going to have to make use of loops, certainly. Do I use a while loop or a for loop? We'll typically use a for loop when you know how many things you want to add. Do I know how many things I want to add? Yeah, because what can I know about the string? The length of the string, right? I want to go around. I want to keep adding characters on based on the length of the string. And it doesn't say in here, I have to say, because it doesn't say whether it's been implemented in an array or a list. So I suppose it's not clear whether I need to validate whether I need to say it's full or not. So since it's not saying it, I'm not doing it. So what am I going to do? Set a for loop. So for, what position do I start in? What's the first index? 0, right? And I'm going to use I short for bingo. And then we're talking about where we go up to. Where do we go up to? Go up to, what was the name of it that we got given? What's the name of the string? Look here. Message is the string, isn't it? Message is the string we've been sent. So we're going to take message. What about message, sorry. Dot length. Now, you see, that's the question. To -1 or not to -1, that is the question. Well, I'm not saying one way or another. Let's look. Bob here. Yes. What is the length of Bob as a message? 3. So it's going to start at 0. Oh. 0, 1, 2, 3, 4. So I start at 0, and then B will go there, and then increment, go up to 1, go up to 2. Do I stop? Yeah. So so this is good because this is going to go. If I say 0 to 3, it's going to go 0, 1, 2, 3. Right?
Yeah.
So that's 4 times.
That's not good.
So we want to go. Your original instinct's correct. If we said, and here we, if we said I equals 1, bingo, it'd be 1, 2, 3, wouldn't it? Although, so we agree it's going to be -1, so we go around the right amount of time, and actually disagree with the mark scheme here. So student caution is advised, but as far as I can see, it's going to be -1. And then what we do as we're going along, we want to add to what? What are we adding it to? So what's the name of the stack? I should indent a little bit, shouldn't I? So message stack, isn't it? Or is it the stack?
This is the stack. Yeah. Onto the stack.
Yeah, look, onto, isn't it say here, onto the stack, message stack. No, that's an example. The example was the stack. A procedure push to stack takes a string as a parameter, pushes each character of the string onto the stack, message stack. I'm gonna do one of these. Boom. And then message stack. Oh, poo. I didn't do that. I mean, I did, but whatever. What do I do? So what was the function we can use? Dot push. It was not clear as do we start at 0? I think we start at 0, yeah. Yeah, we start at 0. Of course we do. Of course we do. Push. Oh, also, we don't have to care about 0, 1, 2, 3. Push takes care of it, doesn't it? We just push. As in, we don't care. We don't have to care about the index where it's at, in a sense, do we? Because we just push. We don't say push onto at position 0 or position 1 or position 2. We just say push, and it takes care of it. So push. Now, here's the bit. What am I pushing? That's the number. No, what am I actually pushing onto the stack? Yeah, the message, right? But let's do this first of all. So I'm going to go down here. I'm going to write it here, okay? Because I'm running out of space. If I just put, where was I? Message. Yeah, here we go. If I do just message on its own, I'll be pushing the entire character to string on each one. So what would that do? If I send it Bob, it will put Bob, Bob, Bob. Yeah, well, if it was a character stack, that's definitely a problem, but that's not what I'm trying to do, is it? So if we did it in Java, I agree with you, it would be .char at position 0. Yeah? Char at is not one of the functions associated with the OCR pseudocode. Now, I would like to think that they would accept if you did char at. Substring is, and I think substring works in the same way, as in like the format of it works. I mean, yeah, there you go. So message, what was the function we're calling? Dot substring. And as you say, we're sending it I plus 1. Oops. I'm going to be consistent with my way I'm writing it. Nobody else cares, but, I try to care. I plus 1. Beautiful. Push. Ooh, another one here. What else? Yeah, the format that they want is next I. What else? I'm done. Am I? Yeah, the pointer went, I don't have to worry about, like this thing, the deal here of the pointer moving, right? So add the I to move the pointer. That's all hidden inside push, which I'm not being asked to care about. I'm just being asked to use it. I don't know whether the next question is, huh? Well, because it says in here, just use push. It says, a function push can be used to add a character to a stack. For example, push. Fine. It might be the next question is, for push, please write down the function of how to do push. That could easily come up. This is just make use of push to use push to stack for. Cool? Oh, another question around text files. An encryption routine reads a line of text from a file reverses the order of the characters in the string. What was an application we could say for a stack? Was to do this, wasn't it?
Yeah.
We said one of the applications for a stack is pushing all the items onto the stack. When you then pop them all off the stack, it will be in reverse order.
Nice.
So Bob will become
Bob.
excellent. But with capital on the other side, yeah, exactly. Lowercase b, O, capital case B. Yeah, maybe I need to pick a different example. It is a palindrome, yeah. And subtracts 10 from the ASCII value of each letter. Oh, okay. So for some things, that's going to turn it into, like if it's a lowercase letter, it will become another lowercase letter. But in some cases, it might become like a number or a character. Because remember, ASCII, you've got all the lowercase A to Z in one go. But if you take 10 off it, I don't know what it becomes. The program is split into sub-procedures. 3 sub-procedures are described as below. Read the string from the file. Push each character of the string onto a stack. Read and encrypt each character. Describe the steps the program would have to take in order to encrypt the characters stored in the stack and save them in a single variable. 5 marks. Go through it again. Indeed. So that it's into sub-procedures. So subroutines, functions, and procedures. These 3 sub-procedures are read the string. Read the string. Push each character of the string onto a stack. And then read and encrypt each character message. And the encryption, what was the encryption element they talked about here? What part of this did the encryption?
Oh, the subtract 10 from ASCII value.
Yeah, subtract 10 from the ASCII value. Yeah? So because when you want to decrypt it, what can you do? Add 10. So there's 2 things you're doing to encrypt it. One, you're putting it in reverse order. And secondly, you're taking 10 off the ASCII value. So when you get it, will it kind of look like nonsense?
Yeah.
Yeah. And then you do it in reverse order. You put it into another stack, right? So now the question is thinking step by step. I'm going to do my always forever the same tip, and I'm going to make people happy by drawing it the way around that they're happy to see. Am I right?
Yes.
I'm going to be like dog. So dog is my message. Let's think about how it's actually going to work. I'm going to need for this, where would the pointer be pointing at the moment? Top. Decrement, pop that off. So G will go over onto another stack. When it's going over, what do I want to do?
Take away 10 from ASCII value.
So let's go through this. Let's think about it chronologically. So the first thing I wanted to do then was decrement the pointer and then pop off the stack. Now decrementing the pointer that's inside the popping off bit, isn't it? So I'm making my little list here. So 1 pop from stack. Once I popped it from stack, what do I want to do? What do I want to do with it? So like this dog has now flown the nest. G is popped off. So I've got G. What do I do with it? Because the next thing I want to do is then pop it back onto this new stack, yes? Not pop, push onto a new stack. So, and what do I do? What did I say I want to do with it? No, but what's the thing I wanted to do? I'm saying when I'm like it's this problem here. Don't worry about the functionality too much. I'm popping the G. I've got the G off here, and then do I just put a G here? I've got to I've got to take away 10 from the ASCII value. So to do that, I'll need to is that an ASCII value? No, an ASCII value would be some kind of numerical number. So what will I need to do? I'll need to convert. You know what? I should have done it here. 1 pop from stack. I should say pop value from stack.
Good enough, so
I'm getting lazy at this point, yeah. 2 convert to ASCII. Yes? What's next? Do what with 10? Yeah, subtract 10 from ASCII. Did it say, now we could just leave it as an ASCII value. I mean, that actually might be better encryption because then you might have to, turn it back again, right? Because it's just a bunch of numbers then. But it says in here, then saves the new string into the same file, I think they want you to convert back again. Yeah? So let's say it was, I don't know, let's say it was uppercase X, that becomes, I don't know, L or something. So convert back to ASCII, yes? Convert back to character, to character. What's next? Push onto it, yeah.